Using the gas laws. It is important when doing calculations involving gases to understand several things. First, when doing calculations, you will be using either the equation PV equals nRT or the equation P1V1 over N1T1 equals P2V2 over N2T2. It is not really necessary to know any of the individual gas laws in either form, because they can be produced from one of these two equations. The second thing to know and remember is what each of the symbols in the equation means and what units are normally used. These are: P stands for pressure of the gas, measured in atmospheres, kilopascals, or torr, which is millimeters of mercury. V stands for the volume of the gas, nearly always measured in liters or cubic decimeters, which are equal. N stands for the number of moles of the gas, measured in moles. T stands for the temperature of the gas, always measured in kelvins, not degrees Celsius. R stands for the universal gas constant, the value of which depends on the units of pressure that we are using. Here are three of the most common units that we use. The third important thing is to be able to tell when you use each equation. This is not a tremendously difficult thing to figure out, but you do need to pay attention to the problem and what you are being asked to do. The distinction is this: if you have one set of conditions, you need to use PV equals nRT. If you have two sets of conditions, you should use P1V1 over N1T1 equals P2V2 over N2T2. One set of conditions means that you have only one pressure, one volume, one number of moles, and one temperature. One of the four variables is the answer to the question, and you must know the actual values of the other three variables in order to solve the problem. The units of the quantities must match the units in one of the values of R. So the volume must have units of liters or cubic decimeters, the temperature must be in kelvins, the number of moles must be the actual number of moles, and the pressure must be in atmospheres, kilopascals, or torr. Two sets of conditions means that we have two pressures, two volumes, two numbers of moles, and two temperatures. One of these 8 is the answer, and we might know the values of the other 7, or we might not know them all. If we know or can figure out that a quantity does not change, we do not need to know what it actually is, because the constant value can be canceled out of the equation. In addition, we can use any units of pressure, volume, or the number of moles, as long as the units are the same for the two values. Temperature, however, must be in kelvins. So, let's look at a couple of examples. Here's a problem. Calculate the number of moles of O2 held in a sealed 2.00 liter tank at 3.50 atmospheres pressure and 25 degrees Celsius. Which type of problem is this? This is one set of conditions. There is one pressure, one volume, and one temperature. So we use PV equals nRT. Here's another problem. A sample of air occupies a volume of 2.50 liters at a temperature of 22.0 degrees Celsius. What volume would the sample occupy in a hot air balloon at a temperature of 43.0 degrees Celsius? Assume the pressure is constant. Which type of problem is this? This is a two sets of conditions problem. There are two temperatures and one value for the volume, but the other volume is the answer to the question. The problem specifically says that the pressure remains constant, and we can reason that the amount of gas also remains the same, since the first sentence says a sample of the gas, and the question refers to the sample. This means that we are talking about the same gas. So, we use P1V1 over N1T1 equals P2V2 over N2T2. In this case, since P and N are constant, they cancel out from the equation. So we actually use V1 over T1 equals V2 over T2.